Subset sum problem. Subset sum problem is a classic decision problem in dynamic programming. What is the problem here? The problem is to find out whether the x is a subset of a given set of numbers such that this subset will sum to a particular value. This is the task. The input provided will be a set of n positive integers and a target sum s. What do you want to do? You have to find out whether there exists a subset of these n numbers such that their sum is the value s. This is the task. You will be given a subset A which is equal to, this will have n numbers, a1, a2 up to an. There are a total of n numbers. What do you want to do? You have to find a subset, a dash subset of A, such that what should be the condition? If you sum all the values in A dash, that is sigma x element of A dash x, that is if you add all the values in A dash, it should give a total S. This is the task. If it is available, then you will say yes, this particular set is having a subset which is having values, which is having some S. Otherwise, you will say it is not having a subset and hence final answer is false. This is the task. Let us take an example here. We'll have a set something like 11, 6, 27. I'm just taking some random numbers to just show you what is the subset sum problem. 5, let us say 9. This is the set from which if I ask you, is it possible to get a sum 18? Is there a subset of elements that are provided here which will sum to the value 18? Is this possible? This is the subset sum problem. You have to respond by saying yes, it is possible, or no, it is not possible. How will you find it out? If you see here, is there any way to add few numbers from this list and get a value 18? Is that possible? It seems the value 18 is possible. How can you get it? 11 plus 2 plus 5. 11 plus 2 is 13. 13 plus 2 is 5. 13 plus 5 is 18. So if you sum these 11, 2, 5, this is the subset from the given set such that the sum of values in this subset is 18. In this case, you will say yes, it is possible. This is the task. We want to see what algorithm can be used in order to get this task done in the least amount of time, that is in the best time complexity. We are going to use dynamic programming here. Let us see how are we going to use dynamic programming in order to solve this problem. I'll provide you the steps first and let us see what is the logic behind steps, and we'll also see a pseudocode in order to know how exactly can you implement this. Okay. The solution for this problem, it should be something like this, that initially you will have a Boolean dynamic programming table. We know in dynamic programming, you should have a table in which you will be storing the values that are repetitively called. That is, there will be a lot of sub problems which are called repetitively. And in that case, instead of solving the problem again and again and again, what will you do in dynamic programming? You will directly fetch that value from the table. This is where dynamic programming is helping. So we'll have a DP table. How much should be the size of your DP table? You should have a DP table. It should have a size of n plus 1 cross s plus 1. What is n here? N is the total number of integers that are provided as input, and s is your target sum. In case of subset sum problem, your DP table should have a size n plus 1 cross s plus 1. The next question is, what should each particular element in this DP table signify? DP table is a matrix. This matrix has n plus 1 rows and s plus 1 columns. In this case, what should each entry in this DP table signify? See, whenever you are learning dynamic programming and you want to store values, first thing you want to understand is what does each particular value in that table signify. Once you understand this, the remaining part is very easy because you know exactly what you are storing. Then automatically you know when you want to fetch it and what is your algorithm. So the whole algorithm depends on what you decide to store in each particular entry in the table. That is where the core of algorithm resides. Okay. So what can be your first step here? The first step here is to define a DP table, and in this DP table each entry, that is DP of ij, any particular entry, this entry should be true if there exists a subset of the first I elements such that the sum is j. This is the condition in order to mark any particular cell in this table as true. And when will it be false? It will be false if you can't find a subset from the set of first I integers. You are provided a total of n integers. You will only consider the first I integers. Using that first I integers is the any possible way of making a sum of j. This is what you will see. In case it is possible using the first I integers, when I say using the first I integers, it's not that the first I integers will sum to j. That is not the point. From the first I integers, you can take any subset of those numbers. Taking any subset of numbers from the first I integers, is it possible to make a sum of j? That is, for example, if your j is 3 and in the first I integers, let us say you have 1, 2, 5 and 7. Here the answer is yes, because from the first I integers, there is a way of choosing some values from it to make a sum of j. That is, if you choose 1 and 2, you can get a total sum of 3. From the first I integers, if there is any way of selecting few integers such that the sum will be j, what will you say? You will say it is true. You can form such a subset. In case it is not possible, then you will say it is false. So at this point, it should be clear for you what each entry in the table will represent. Then we can move on to the next part. What is the next thing? Next thing is, you have to understand which entries can you directly say as this is always true or this is always false without any verification. Which are the conditions that will come as base case? Among those conditions, the first thing is the first one, that is DP of 0, 0. That is the leftmost, topmost particular block. What will be the value of this particular block? Just think about this. This says there are a total of 0 integers and you want to make a sum of 0. Is this possible? Yes, it is possible because with no integers, whenever you have no integers with you, by default the sum is 0. Because there are no integers, sum is 0. So this is always true. This condition is always true. What is the other condition? You can say that this thing is always true or this thing is always false. Let us see one more thing. That is, if you have DP of 0j, if this comes for any value of j greater than 0, you can always say that this is false. What is the reason? Why can you say this is always false? Because this says there are a total of 0 integers with you and you want a sum of j where j is greater than 0. When you have no integers with you, how can you get a sum greater than 0? That is always not possible. So in this case, you can say it is always false. Whenever it is dp00, the first block, this will always be true. And those blocks which are having 0j, when will you have 0j? That means it is first row. In the first row, all other values will be false. These are the base conditions you can have. Next thing to understand, once you got the base condition, how are you going to fill all the other entries in the table? Once you understand this thing more, you are done with this. You can start doing it. Okay. How can you fill each of the other entries in this table? Let us say any particular entry dpij. In order to fill that, what you want to understand is what is I? I is the set of numbers you have and j is the total sum you want to find out. Here, when you are filling the ith particular block, that is for dpij corresponding to the ith row, you know you are going to add one more element to whatever you did previously because you are filling it in order. So you'll fill one row completely, then the next row, then the next row, and so on. Whenever you are filling any particular value dpij, you already know you already filled the value for dpi minus 1j. This is what you already know. This means you already know what is the solution if you have I minus 1 numbers under consideration and you're trying to add ith number also to that set. You're trying to add ith number to the set and then you are trying to find out whether some particular sum is possible or not. This is what you are actually trying to do when you are trying to fill dpij. What are you going to do? You're trying to see whether ith value can be considered or not. This is the task. Then you have two options. What are the two options that you have? The first option is you can add the ith element. This is one option. Second option is you can remove the ith element. That is, either you can consider the ith element or you can not consider. What is the condition under which you can never consider this element? That is there any such condition where you can never consider this element at all for this subset sum? It seems there is a condition, and the condition says if it so happens that the value of that element, let us say ai minus 1. Why am I writing I minus 1 here? Because the input, let us say the input array is called A is having n different integers, then the index will be from 0 to n minus 1. That is why for the ith integer I am writing ai minus 1. Okay. So for ai minus 1, if this is greater than j is the total sum you want to make. If this particular value is greater than j, then you know that including this value, anyway you won't get the sum j, because along with this, if you add any more number, it is only going to be larger than j. It is never going to be smaller than j. So whenever that particular value that you are considering, the ith value, if that is greater than j, you can always say that it won't be possible. So in this case, you always have to exclude. In this case, you have to exclude the ith value. What is the case in which you can include the ith value? The other case of this, that is whenever ai minus 1 is less than or equal to j. In this case, you can include the ith value because this particular value is lesser than the sum. So there lies a possibility that by including this value, you may get a sum s. This is the possibility. So at this point, sum is j. Okay. Then again, you have two considerations here. In this case, when the sum is lesser than or equal to j, that is ai minus 1 is lesser than or equal to j. In this case, you have two options. One is you can include this value. Second one is you can exclude this value. Why are the two possibilities there? It may happen that even though this value is lesser than sum, it may happen that there is no possibility of a subset which includes this value and gives you a sum. Sometimes it may be possible that with the remaining I minus 1 elements, you may be able to make a sum of j, but including the ith element, you won't be able to. So in that case, you won't include ith element in the subset. The other cases, you may include ith element in the subset, but once you include the ith element in the subset, what is the change that is going to make? Let us see exactly how dpi minus 1 value will be formed. So here, in case it is greater than, in that case, how exactly are we going to form the dp value? And if it is less than, how are we going to form the dp value? In case it is greater than, the dpij, this particular entry, this entry can be filled as whatever is the value present in dpi minus 1j. dpi minus 1j. What is the logic behind this? The logic behind this is, you anyway know that ith element can't be included because it is larger than the total sum that you want. So you are saying that whatever is the result of using I minus 1 elements, The same will be the result for using I elements. That is, if this is true, this will also be true. If this is false, this will also be false. So you'll simply copy whatever is the result with I minus 1 elements. That is one stage. The other thing is, in case the value is lesser than j, the sum to be obtained, then what will you do? In this case, you have two options. One is you will do the same thing. That is, you will not include and you will simply use the I minus 1 elements. Otherwise, in case you include, then what happens? Then your dpij updation becomes different. Once you includes this, then what will be the updated value of dp? Then this will be dp of I minus 1. Then this will become j minus a of I minus 1. What is the logic here? Why did I write like this? This is because if I am including this value, what does that mean? From the total sum that I want to find, from the total sum j, whatever is the value of a minus 1, that is already contributed by this element. That means using the remaining elements, I want to find whether a sum of j minus 1, ai minus 1 is possible. If this is possible, then this is true. Otherwise, this is false. So here again, what you are doing is, whatever be the value of this particular entry, that you are copying onto dpij. This is what you are doing. So how can you write this in a neat form? Instead of writing like this, I can write this as, in case the value is greater than j, then this is what happens. In case the value is lesser than j, then how will the updation happen? dpij, this will be equal to, how can you write it in a neat form? dp I minus 1j in case I am not including, or it can also be dp I minus 1j, or it can also be, what can it be? dp I minus 1. What did we just discuss? This should be j minus a of I minus 1. This is what we just discussed. This or is actually an or statement. That is, if either of these is true, then you can say dpij is true. This is the situation. So you will go and check dp I minus 1j. You will also check dp I minus 1 j minus a of I minus 1. If either of them is true, then you will mark this as true. If both are false, then only you will mark this as false. This is the condition. This is what you have to follow, and you have to fill the complete dp table. What we'll do, let us write the pseudocode for this. That will make the things clear. Once we write the pseudocode and see with an example, if you see exactly how we are going to fill this, then the whole idea will be very clear for you. Let us try to write a pseudocode. From pseudocode itself, you will get basic idea of what all we learned. In the pseudocode, we are going to write the steps. Okay. Steps we already know. So we'll just write it in a form such that it will be easier for you to implement. Subset sum. Subset sum is a problem. What is the input? Input is an array A and a target sum S. These are the inputs that are provided to you. What will you do now? First of all, you need to find out what is the length and all. I'll write those. It will be better to write n is equal to length of array A. This is the first thing you want to know. You should know what is the length of array. Why do you want n? Because according to that, you want to form the dp table. What will be your dp table? This dp table, this will be of size n plus 1 cross s plus 1. This will be the size of dp table. And what are the conditions here? You should have first row as false. So I'll write it here. First row should be false. Then what about the first column? First column should have value true. And then one more thing is the first entry, that is dp of 0, 0. This should be having value true. Why did I write this separately? Because this is part of first row as well as first column. So I don't want you to get confused. So I specifically wrote what happens with dp 0, 0. So you already know, right? Why is the first column first row false? First row false because first row says dp of 0j. That is, sum is the number of integers you have is 0 and the sum you want is j. So without any numbers with you, you can't generate a sum j. That is why first row is false. What about the first column? First column says dp of j0. This is the first column. First column says you have j integers with you and you want to find whether a total sum of 0 is possible or not. A sum of 0 is always possible because you simply say I am not including any of my numbers. Then your total sum is 0. So whatever be the number of integers you are holding, you can always generate a subset which is having sum 0. That is an empty subset. That is why first column is always true. Why is dp00 true? For the same reason dp00 is true. Let us go to the next step. What is the next step in our algorithm? We have to go through each of the numbers that are provided. For each of the number corresponding to each of the value till you reach s, you have to update the table because you have an n plus 1 cross s plus 1 table. What will you do for each row? For I is equal to 1 to n. What do you want to do for I equal to 1 to n? For each of the row, you have to fill value in each of the column. So for each of the column, you will write for j is equal to 1 to s. That is for each of the column. What are you going to do for each of the column? First thing is you have to check whether this particular value, ith value, is having the value greater than the sum you are looking for, greater than j. So the condition should be if a of I minus 1, if this is greater than j. In this case, you can't include, you are very sure, because you want a total sum of j. So including this ith value doesn't make any sense because its value itself is larger than the total sum you want. So what will you do? You will do dp of ij is equal to dp of I minus 1 j. This is what you are going to do. This is I minus 1 j. What is the other condition? In case this value is less than or equal to j, that is else case. Else case, what will you do? You have two options. Either you can include or you can not include. So you will write dp of ij. This is equal to either you will not include or you will include. Both are possible. So dp of I minus 1 j is one possibility in case you are not including. What about if you are including or I'll write or itself here. Or what will be the condition? dp of I minus 1. What did we learn? This should be j minus a of I minus 1. So these are the two conditions. What should you finally return? Once you are done with this, you should finally return whatever is the value present in dp of last entry, that is dp of ns. What does this entry say? This entry will tell you whether a subset of n numbers can form a sum s. This is what it will tell you. So let us just have a quick look at the algorithm that we have written. Here what did we do? Initially we found out the length of the array. Then we defined a dp table which is of the size n plus 1 cross s plus 1. In that, what is the initialization? First row is all false, first column is all true, and dp00 is true. Then we started looping through for each of the row, for each of the column, that is for each entry dpij. What should you do? You should see whether the ith element is lesser than j. In case it's greater than j, if it is greater than j, you can anyway not include. What will you do? You will say dpij should be whatever is the value of dp I minus 1 j. If it is true, you will copy true. If it is false, you will copy false. If that is not the case, in else case, that is ai minus 1, the ith element is having a value lesser than or equal to j, that is the target sum. What will you do? You have two options. You can either not include this ith element and see the sum with I minus 1 elements, or if you include the ith element, then the remaining element should be able to make a sum which is j minus the value of ith element. This is the logic. Finally, whatever is the last entry of the DP table, DP of ns, which says whether a subset of n numbers can form a sum of s. If that is true, then the whole final answer is true. If it is false, the final answer is false. This is the DP solution. What about the time and space complexity here? You are filling one complete table which is of size n plus 1 cross s plus 1. So what should be the time complexity? Order of n into order of s will be order of n into s. So order of n into s. This will be the time complexity. What about the space complexity? Again, the additional space used is for the DP table. The size of DP table is order of n into s. So your space complexity will also be order of n into s. This is the DP solution for subset sum problem. What are we going to do in the next lecture? In the next lecture, we'll take an example and then we'll illustrate how each entry is filled in the DP table. From that, you'll get a clear idea of how this algorithm is working. And after that, we'll see what is a space optimized solution for the same problem. That is, instead of this table, can you optimize space and use a single array instead of this table? This is what we'll see after that.